Okay. Hello, everyone. My name is Chetan, and I am one of the leads in this Intro2Astro 2025 this year around with Faye and Howard this time. I'll take this session on Git and GitHub for you guys. Just a bit of background about me. So I am currently a tech consultant working in the industry on data, science, data analytics, and data engineering problems. While I also worked with ASIAA in Taiwan as an astrophysics researcher for around a year in 2021 to 2022. And I'll be taking this session in a way that this is useful for you in an astronomy setting, right? When you are studying astronomy, there are certain parts of Git and GitHub you'll really need to use extensively when you're collaborating with people or just you're working through your projects. And yeah, I'll skip out the nitty-gritty details of the whole thing, but yeah, I'll keep it relevant to you. So I'm not going to too many details. All right. So starting off, what is Git? So Git is basically a kind of a source or a version control system. And what that means is to say that whenever we are making a project, we want, to save some kind of versions of it. So in a traditional setting, what you would do is in your own projects, you will have a folder, right? And in that folder, you'll have all your codes or maybe whatever you are writing in case that's a, text-based project or something like that. So you'll have kind of versions of this folder, like version one when you are, initially doing some stuff, then version two when you are making some changes on top of it, and then version three, and then leading up to the final version. So a source control system or a version control system is, making this whole chain of changes, a bit easier and a bit more, usable or kind of a way that you can find each of these changes individually when you were making these changes, right? So this is a version control system, and Git is one of these version control systems. So it allows us to do this versioning of your project or a folder in a more flexible manner and a more useful way so that we are able to use our code effectively. And what it means is it maintains the history of all the changes that we have done in our, in that folder that we are calling our project. And then it is tracking all the changes as deltas. So by deltas, I mean increments between what is present currently and what is present in the next version. So a difference between these two is that is what I'm calling a delta. It also allows us to do collaborative work that we'll learn in the later half of this presentation. And why is basically Git useful for us? I mean, why not just make those versions of the folder? So a few of the advantages of that is are listed over here. So that first of all, we can revert to any of our versions. Like we do not have to, go and find which version we want to revise to. And then we have a maintained history of all the changes in our code. So it will, guide you through what change you made when, right? So that is it. Then you can collaborate with multiple people, right? So this is a collaborative advantage that, again, as I said, we'll talk about in the later half of the presentation. And then the another version, another benefit of using it over using it as like different folders is that it takes less space because it is not actually saving the whole folder in versions. It is only saving the changes that you're doing from one version of your project to another version of your project. And then it also is tracking changes between these different increments. So, I mean, you can see a meme over here. I'll try to be as much engaging with you as possible through these memes, but yeah, these might be a bit outdated as well. All right, let me move on to how Git works to, enable this. So again, as I said, I'll not go into too many details of what Git is, and basically, I feel that a lot of people do not really understand Git, but they do understand it enough to make it working, which is really all we want in astronomy, right? We do not need to code Git itself; we only need to use it as a tool. And a lot of these slides would have references from Dr. Jason Wang's slides in Code-Astro, which is another astronomy workshop that takes place that I was part of. And you can find it over the link. I'll share this with you. The slides will be shared with you. All right. So I'll throw on some terminology and some commands that we use in Git one by one, and then I'll explain what each of these command does and then how a Git structure is made. right? So first of all, we have a Git repository, which is, a proxy for your own project folder. So a Git repository is a folder that has some kind of tracking enabled. And how is that enabled is basically we initialize Git in this folder. And when we do this, when we initialize Git in this folder, in our project folder, it creates a .git subfolder which captures all this metadata that we were just talking about, the increments between the files and what files you have in this whole project and how they are changing over time, what changes you are making at what time, then maintaining that history, and all these kind of metadata are stored in this subfolder, in this .git subfolder that we have created when we are initializing our folder as a Git repository. So think of Git repository as a collection, right, for your own project where you are storing your files, which is the one part, storing all your code, storing all your images and everything. And then you have a .git folder in this particular folder, a subfolder. This subfolder contains all the metadata of all the versions and all the changes that your folder is going through. And to initialize any folder, so you can do this with any folder whatsoever. To initialize any folder as a Git repository, we need to use the command git init. So it initializes that folder as a Git folder and makes this subfolder .git. Okay, so this is the first part where we are telling that this folder, I need to enable tracking on this folder, which I have done using git init. Then moving on, I have an example over here. So I am in a I'm in a folder called example tutorial over here. I have not initialized Git yet, but as I write the command git init on my terminal, it throws up a bunch of hints. That is when it's creating this folder as a repository, and at the end of it, it says that initialized empty Git repository in this particular folder, right? And then there is a .git subfolder you can see under this example tutorial folder that I was just talking about. So we have successfully initialized our folder as a Git folder or a Git repository. Now this was the first part. My folder is currently empty. I have just initialized it as a Git folder so that it can track any changes that are coming forward for it. So what I need to do is I'll add a new file to this folder. Okay, and let's say that we need to create a new Python file. So I have created a new Python file that is called python example.py, and I have just written down a bunch of code over here. So we have like welcome to Intro2Astro 2025. We will use this file for Git and GitHub tutorial, and then I have initialized two variables and then set their values as blue and red. So ball 1 is blue, ball 2 is red, and then I'm just printing the colors of these two balls. So a very simple Python file. We can have any file of any sort in this folder, but yeah, I've just taken this as an example right now. So we had this folder that we initialized with a Git as a Git repository. Then we added a new file to this folder, which you can see on the bottom left, that in this folder I have this python example.py, and by default, since it's a Git repository, there is a hidden .git subfolder in this. Okay, all right, moving on to the next part. So now I have a folder which has this file. How do I tell Git to track this file? So that is the second part. It is currently not tracking this exact file, it is just tracking the whole structure of the folder. So how to check what is being tracked and what is not being tracked? So git status is one command which tells us the current status of all the files that are present in this Git folder, both tracked and untracked. And as we added this new file, right, the Python file, so if I do a git status in this example tutorial folder, you can see that it is saying something like no commits yet on branch master. We can ignore these two for now, but then it says that there are untracked files. So this is the file name that is untracked. Then it also tells us a hint that use git add file to include in what will be committed. What this means is there is a file in this folder that Git is not tracking as of now. If we want to track any changes in this file, we want to add this file. So this is the second part of what we were going through, which is adding this file as a trackable file in GitHub or Git. And what is used here is this process is called Git staging, which is used to add a file for tracking its changes on a kind of a staging environment or staging layer. So once a file is added, once we use a git add command for adding a file under what is to be tracked, any changes that are made in this file are tracked by Git. So in case we have a large number of files, we can also use git add star, but in our particular example, we just wanted to add one particular file, which was example Python. So I'll just add git add example python.py, which adds it to the tracking layer. And then there's a word of precaution that when you're using all files using this star, you have to be careful of what you are really adding, right? So you can specify what to ignore, what to add, which you can see over here and Google further as well. All right, so what I'm doing is just showing you that same example. So I have added this python example.py git add using the git add function or command, and then I'm checking the status of my repository currently. So if I do git status, it still says that I'm on branch master. Ignore this for now. No commits yet. Ignore this for now. But it says that there are changes to be committed. That is, it is now tracking this new file, which is python example.py. This is in opposition of what we saw earlier that said that this file was not added, right? Okay. I'll move on to the next part. So what's a git commit? It just said that we have a
Then
file.
board number.
Sorry. Yeah. So we had a file to be tracked, right? We added that file python example.py, but it said that changes to be committed. So what's a git commit? It's kind of the most fundamental unit of the Git mechanics or the Git structure. What it does is it logs, or maybe you can say when you are pressing Control S or Command S on your laptop, it saves a current version of whatever you are working on. So commit is the same concept. You are saving or logging one version of your files in Git, right? So whatever status I am at, I want to save that as a checkpoint. So think of git commit as a checkpoint, and when I write this command git commit, it saves a block that has all this information. I mean, you do not have to read through everything, but it has like a ID, it has a parent ID, it has all the changes that were being made. You can add a message to this commit that I made XYZ changes to abc.py file, right? And so on. Then it has the author, the email, and the timestamp of when this change was made. So all the metadata that we were talking about, right? These are all being tracked as part of these checkpoints, which are called commits. So in our example, I started with a with a empty folder. I initialized it as a Git repository first of all, and secondly, I added a new file and wrote down some code in that. Third, I added that file as a state at the staging layer, which said that I want to track this particular file, all the changes that are made in this file. And fourth, I want to now save my progress with this file and with this whole repository as a checkpoint. So this fourth point where I'm saving this progress as a checkpoint is called the git commit. And the usefulness of this commit is basically we are having these different checkpoints in our system, in our git repository, and what we can do with these checkpoints is we can revert to any of these checkpoints at any point in time. So moving on, it commits or holds all the changes that are compared to a previous git commit. So the incremental thing is done over here, right? One commit to other commit, one checkpoint to other checkpoint. We have the saving of the differences between the current position and the next checkpoint, right? And typically what git has is kind of a, I'll just show you that part, give me a second. Yeah, so look at the image on the bottom left over here, right? We have kind of a chain of these checkpoints which are called commits. So on the extreme left we have the beginning of a new basically new branch, or you can say a new repository. Then we make checkpoints, so commit 1, commit 2, commit 3, adding new files, changing new files, and so on. Then let's say in the commit 4, in the checkpoint 4, I introduced a kind of a bug in my code, right? I did a mistake. I did not look at it at that time. I went on and did another checkpoint, commit 5, and then commit 6. I realized in commit 6 that, oh, I made a mistake in my code. Now I want to roll back to a checkpoint that was safe, that I know that I did not make that mistake in. I can go back in time from this last checkpoint to the checkpoint that I made this mistake on. So commit 6 to commit 4. And this is how a Git repository basically works. It has this chain of checkpoints or chain of commits. Okay, moving back to where we were. All right. So in case of the first commit, everything that we are tracking in this repository would be the first version. So it would save everything. Then going forward for each commit, it will save the increments. And then if we think about our current example, so we were at the fourth point where we wanted to make this checkpoint with our Python file. So if you look on the top, we have this git commit. I have written this command git commit. Then -m tells us a message that we can write so that it's useful for us to refer to later on. So what I did in this commit, I have written initial commit, added file example python.py, and what it does is it commits, or it saves this checkpoint. It says that I have inserted one file. There are 8 insertions, so these are the number of rows that you must have saw in our example code. And then it created a mode, so basically that there is an ID for that particular checkpoint that it is assigning. So I have saved everything right now on my git. Right, and if I do a git status now, like what's my status of the repository? So it says that I'm on branch master. Again, we can ignore it for now. I'll discuss it later. But then it also says that there is nothing to commit. Working tree is clean. We are at the, we have committed everything that we have, worked on in the past whatever time, and we are up to date with whatever changes are there in my whole folder, which is being tracked. Okay. So we have talked about making these changes. So let's say that I make a new change. I add a ball 3, which was of green color, and then I add a print statement. So I want to make this change. What I'll just simply do is check get status first. Since this file is already added, it will already be tracking all the changes. Whenever I make a change in this file, it will say that changes are not staged for commit. I'll again add this file, git add python. It will add all these changes to the staging part, and then I can commit that added a new ball in example python.py, right? And then it will make another commit or a checkpoint. What this checkpoint will do is it has one file that was being changed. There were 3 insertions, so this blank row, this ball 3 row, and this print row, and then one deletion. So I think there was one a new line row, but that was being deleted. But yeah, it says that what is being changed, and it has saved it in a new commit. So the ID of that commit, it has written over here. If I want to ever roll back, if I want to see what commit contains what data, I have added this message for my own reference. All right. Yep. So before I move to Git branches, because I mean, this is mostly the functional part of Git that we will be learning today. Any questions so far? Yeah, go ahead, Amy.
So this is kind of like some systems I've seen in some CAD programs and stuff like that, where they'll have a system of named, saved edits. But in the main thing that I would want to clarify is if you go back, you do lose any progress that you had after that, right? And
Yes,
yeah,
yes. But
but
the thing is, Avi, if you roll back, you lose progress in your current commit, but you still have this checkpoint saved with you, so you can refer to that at any time.
I see.
Yeah.
So it's more like a window snapshot.
Sorry, Raj, your voice is a
Yeah.
bit low.
Yeah. So like in virtual machines, we can have a snapshot of an OS. Is
Yes.
this like one of them, or like the
Yep,
save
yep.
games we have?
Exactly. Yeah, yeah. If you have worked with virtual machines, yes, this is exactly the same concept, right?
Yeah, I have worked with them. That's why I was asking.
Yeah. Yeah, we go ahead.
Sorry, one more thing. So if you go back, if you went
Mhm.
back to 3 and then you made a new save, would that one be labeled 7? Or would it?
Yes,
Yeah, I see.
it
Okay.
would be. Right. Yeah. All right. I think all the questions are answered. All right. I'll answer some of the leftovers at the end of the session. But yeah, I think we should be good over here. All right. So I'll move to two more, concepts. One is the Git branches and one is Git merge. I'll not go into too much detail because you might or might not be using it very frequently. But the concept is that you can have parallel branches of these Git commit trees. So we were talking about 1 to 6, right? Git commits, checkpoints. So let's say that I want to work on a very different, kind of a feature of my own whatever project I'm working on, or if there is someone else who is working, or different user altogether who is also working on the same project on my laptop. We do not want these two, branches to be anytime, conflicting with each other. Any changes that I make in the code should not conflict with the other branch. So we make two parallel set of branches, or n number of parallel set of branches, and then each of these branches could have a different set of commit tree, right? And what happens is that at the end we need one project, which is why everything is in the same repository. So there is a concept of git merge, which on the right you can say that if I have a few changes that I was doing, then someone made a branch and I added a new feature over here, or maybe some other user came in and did some change on this particular branch, I can merge this with my main branch which was going on over here, right? And then merging this means that all the changes that I was doing till this commit and all the changes that were there in this commit would get merged together, so that it creates a final version of my project. Now, as you might guess, that this might have, conflict. So if both I and the other user were working on the same set of, code, there might be cases where I and the other person would be editing the same line, and the line would be different in both our files, right? So in this cases, we need to have, we have merge conflicts when we are trying to merge these two branches, and Git asks us to, manually resolve this conflicts by choosing the correct code, or making a hybrid as we see fit. So it's kind of manual process at that point, because for Git, it does not know which one is correct. There are two different things on the same line, on the same code, on the same file, right? It needs to ask us what to take, what not to take. So in this case, let's say in my main branch, in my head branch, which is the main branch that I was following, I have written print1, but in the other user's branch, in the same file, they have written print2 on the same line. So it flags us this case as a merge conflict. We have to, resolve this conflict in order to merge these two. So this is how, as I talked initially, there are different users who can work collaboratively on the same, repository, on the same project. So they can work independently as different branches, but when they are trying to merge, they need to make sure that they are not working on the same file, on the same line, and still giving different versions of the same thing. So that is how we collaborate through this Git. All right, to the last part of Git, and I'll move to GitHub, which is a shorter duration thing. First of all, installing Git. So for Mac users, great news. This is already installed, and I feel that Mac generally does things like this. So it's a Unix-based system. In Ubuntu as well, I think it's installed. No, it's not installed. Sorry, my bad. In Windows and Linux users, for Windows and Linux users, you can install this using the Git SCM. It's a free software. You can install it and you can use it on your local. And then trying it on your own. So let us try what we just discussed and, summarize it. So we had these four things basically. We first of all created a repository for Git. Then we added files for writing code, etc., and then staged them for tracking. So Git add file name. Then we can check the status of the files and the whole repository using Git status. And then whenever we are ready to make a checkpoint of what we need to, whenever we are working, we need to make a checkpoint and save certain progress, we make a commit change. So Git commit -m is for the message that goes with the, this checkpoint. So this commit contains that change. So this is all we discussed. This is all you need to really know for Git part in astronomy. And then moving on to GitHub. So GitHub is it's a website that hosts these Git repository, like for everyone to view. They can be private GitHub repositories as well, but it's the same concept. We have Git on local on our computers. If we put them on a web, so that anyone, not just your collaborators, but anyone in the world can, work on your code, or, use your code, or maybe improve your code. That part is called open source, and GitHub is one way to enable that. We have these repositories saved over a, online platform. So how to use GitHub? We can create an account on GitHub. Again, it's free. And after you make your own account, we can create a new repository. And if we are working on a completely new project, let's say I do not have anything on my local computer yet, what I can do is I can make a repository on this GitHub website only, and then we can use a git clone. So git clone is a, it's a option, it's a command again of git that clones this repository from this online website, the GitHub, to your local machine. So it clones it, right? And then we can work with this GitHub repository, Git repository on our local at our own time, and make these checkpoints and so on. And once we are ready to, push all these changes that we were doing on local, push all these checkpoints and every file and everything that we were working on to this GitHub repository, we can basically git push. So all the changes would be pushed from your local to the GitHub website. So for our case, what we'll do is, since we had already, started working on an existing project, right? What we can do is we can add this, this GitHub repository, this Git repository can be connected to a remote GitHub repository. So what we do is git remote add origin. What this does is it creates a GitHub file on GitHub, right? It creates a git folder or git repository on GitHub, right? And what we can do is we check which branch we are in. So we are the main branch is the one that usually is used unless there is a branching need, right? So we can go to git branch, and then we can git push, like as I said, push all the changes that were present in our local. So whatever we did with our file, that we can push to GitHub. So this is what we are doing by using git push command, and then everything that I was working on, they were compressed and put on GitHub. So to this particular repository. Okay. Yeah, this is something that whenever you're working on projects and using Git, so do not forget to push your changes once you do commits, because this is a step that most of us would forget at some point or the other. So I mean, if you do not push the changes to GitHub, your collaborators might not be able to access the code that you're working on. So it can be a private repository where select few people are working on this repository, or it can be a public repository where anyone can work on. But git push is one way so that you are connecting with these collaborators. Okay, yeah, so in our case, so there is one more thing, I'll talk about it with the example. So for our particular example, this is your assignment as well. I have explained it over here, then what to do is also written later on. But when we are working with collaborators such as ourselves, so in Intro2Astro 2025, we have a repository, a GitHub repository that is hosted, a Git repository that is hosted on GitHub under Howard's page. So Howard has this Intro2Astro 2025. What we want to do is we want to make an own copy of this GitHub repository, so that we are able to make changes onto this and do our assignments and so on. We can put all our assignments on GitHub as well. So this is done using a fork button. What that does is it creates a copy of this whole repository under your own username. So you will have for me it's Chetan Chawla, and then a repository in your own GitHub that would copy everything from this Howard's repository under your own repository. Then once we have this on GitHub, what we need to do is we can clone this repository into our local, so that we can make the changes in the code and look at the code essentially. After we are done with making these changes, we can push these changes back to our own forked repository on GitHub. So once we are done, we'll push these changes, and these changes would go on to Chetan Chawla /Intro2Astro, or whatever your username is /Intro2Astro 2025. Then in the next week, when Faye would make another change or another instructor would add new tutorials, what you do is we can pull the data. So it's not written over here, it is written over here. We use git pull to download any changes that are present in GitHub repository, but not on our local repository. So anything that Faye or anyone else is making a change on the main repository, right, on Howard's repository, what we want to do is we want to first of all check if there are any changes in the main repository, which we'll need to do. If so, we'll pull just a version of these latest changes from the Howard's repository to your own repository. You can see a button on GitHub for this. Once you are done with that, we need to fetch these changes, latest changes, to our own local computer. For that, you use the command git pull, as it's written over here. And then once we have pulled these changes, hopefully there are no conflicts as we talked about, but in case you're working on a separate file, your answer files or your assignment files, you can push these changes to your own version of this repository. So whatever your username is, slash Intro2Astro 2025. So this is how we'll work with collaborators. And the last part of it is, let's say that am I'm a mentor, which I am. I mean, no need to say it, but yeah, I am a mentor. So when I want to upload this particular case or this particular slides to the GitHub, what I'll do is I'll add a pull request, which which says that whatever I have on my own GitHub repository, this Chetan Chawla slash Intro2Astro, I want some files to be loaded into the main repository, which is Howard's repository. So this is the last part. I'll just briefly tell you about the summary and then the assignment. So we talked about cloning a repository onto our local. Then we can again move with the same workflow that we were just talking about. We can add a file name, then we can commit the changes, we can push things on this remote repository, and then we can also pull changes from this repo in case someone is making direct changes to this repository or someone else is also pushing things to this repository. I hope if you hated Git, now you hate it less because you are able to understand some of it. And in case of fire, this is the usual occurrence that you need to do: commit things, push things, and then get out. This is the usual workflow that we follow in every industry and every place. And then this is the assignment, so I'll just leave it for you to do. But this is something very simple that you'll need to do. Just make your own clone of the Intro2Astro repository, and then paste your assignments from week 1 and 2 in the respective folders. And then you just push your changes. You can share the links to your GitHub repositories on the link that I have pasted in the slides. I'll share these slides with you. But yeah, this is it. Thank you for listening. For any questions, feel free to. I think we are over time, but yeah.
Thank you, Chetan. Yeah, we do have a few questions remaining.
All right, yeah. Feel free to unmute and ask. Yeah, Abhi, go ahead.
Well, that was just the clap.
Oh, thank you. Okay. All right, yeah, go ahead, Lavanya.
So you have created an example folder and file earlier in your PC and then pushed it to Git, right? So where exactly is it going to? I mean, do you have to create a folder already in GitHub, or how does that work? It's clear.
Once you push these changes to the remote, or once you connect, so this part, once you add git remote add origin, it will first of all ask you for your username and password so that it can connect to your own GitHub account. But other than that, it will create a Git folder. So if I hope I have it open. I'll just see. Give me a second. But if you basically look at the give me a second. Yeah, I have it open. Yep. Are you able to see my browser screen?
Yes.
Yes.
Okay, great. So if I were to go, this is my own, repository. This is my own profile. If I go into my profile or maybe directly into my repositories, so these are all my repositories. So it creates a folder like this. So Intro2Astro is a folder. Once I connect or do that remote origin, it will create a folder using the name that you have given to your repository, and on which but before that you'll have to connect with your username and password so that it knows where to push this.
Okay, good. And also, when you're cloning, you are actually making another copy of the repository in your local. Until you push it, it's not changing anything, right?
Right. So cloning is required only when you are, working directly on something that is present on GitHub and not on your local. So it's only required to, make a downloaded copy of this repository on your local. In case you are working with a folder that was already existing in your local, and you want to connect it to GitHub that is not present on GitHub, you do not need to clone. You need to just add it to the remote origin thing.
Okay, got
So
it.
for cloning, there is this button over here that gives you the URL. You can just copy paste this, and then on your local write git clone and add this URL so that it can download a copy. And then you can see that this is forked from Howard Isaacson. So you'll have to just go into Howard's repository. You'll have to fork it to your own repository. Once you do, you'll have this sort of thing where all the latest changes from Intro to Astro to 2025 would be under your username. And you can basically make any changes to this, and that won't affect the main repository. And it also says that this branch is up to date with the master, right? In case there are any changes on the main repository, Howard's repository, you can sync fork over here, so that will have all the latest changes from the main repository to here. And you've already, I'm assuming if you want to, or if you have not already, you can clone this repository using this particular URL. Once you have it in your local, make any changes, do anything, commit those changes, make checkpoints, then push those changes. Once you push those changes, those would be reflected on this page, on the GitHub page, and then you're good to go. And in case you want to contribute, so contribute means that you are adding something that you think also should be on the main repository. So those are not your assignments, but maybe let's say a new assignment by any mentor. You can go to this contribute and open a pull request. Currently it's not open because there are no changes over here, but as soon as I put this slides in this folder, I will see a contribute option, and then opening a pull request, which Howard or someone in the admins of that repository would accept and or reject to be present in the main repository.
Sorry, I think I kind of lost you on the last statement. So whatever assignments that I'm uploading, they will not change the Howard's files,
Yes.
is it? They just stay in my folder. That's it.
Correct, because you have forked that as a copy of yours.
Okay, got it. So even after committing, I'm not changing anything to the original thing. Original
Correct,
data
correct.
is still like that, unless
Exactly.
somebody approves it. Okay, this makes more sense. Thank you.
Yes, exactly. You can change it, as I said. So you can contribute, but there is a approval process. So pull request is that process.
Yeah, got it. Thank you.
Okay, go ahead, Yuvraj.
So, it's a little doubt when you install Git,
Mhm.
and then do we open command prompt from the folder where we installed it?
To install it, you can just download it. Once you download it, it will give you a command prompt of its own for Windows. There is a command prompt of its own that you can use. So you do not need Unix or anything for that. You can directly use it on Windows as well, but you will get a command prompt of Git. So it's called Git SCM.
Okay, and there are the commands, etc., and paste my
Yeah, you can
data,
write the
and it
commands
would
on that.
and that would redirect me to my own GitHub page, right? I mean, edit the
Yes.
changes, etc.
Yes. So you can link it to your own GitHub page. Yeah. True.
Okay. And one thing, forking is basically making an online copy, right?
Yes.
For a local copy. Okay, thank you.
Yeah. So GitHub is making an online copy of our local copy. Arif, do you have any questions?
Yes, I had two questions. One was, do the changes that GitHub records, are those changes only within the document, or say I change the file name to something different? Will it record those changes as well?
It will change it will log everything. So you are in a folder, right? That whole folder is a Git repository. So it
Okay.
checks for everything that is changing, even the file name changes and so on. However, you'll need to, if you change a file name, you'll need to basically add that file again, because now it was tracking the earlier file name. Now it is tracking a new file name. So you'll have to,
Okay.
add that new file name and remove the earlier file name so that it is not lost at any point.
All right. Also, the second question was, since a lot of people do use GitHub, how is it free for everyone? Like they must have some
There are paid
server where
plans.
they're
So for public use, it's completely free. You can put any number of repositories, because again, it's helping everyone, including them. GitHub is also based on some kind of open source platforms, right? So open source is supposed to help everyone. I mean, one person gets help from open source, he will put something on open source to help others. So it's kind of that kind of a platform. And then there are donations, of course. So all of the Python libraries that you're using, for example, NumPy, SciPy, the Matplotlib, and AstroPy, all these libraries, there are not organizations that are supporting it, right? There are only donations that organizations do to support these. So all of open source is based on goodwill in a way,
Okay,
right? You
all
are
right.
making these things open source, but there is, so Microsoft, I think, purchased GitHub, and it had made certain part of it premium kind of thing, so you can privately collaborate with a lot of big teams. So that part is paid. Like, let's say you have hundreds of people on your team working on the same repository, that needs to be absolutely private in your organization. So that part is paid.
All right. Thank you so much.